All right, thank you for that introduction. I want to talk today about what I call responsible disclosure. And it really is a dilemma in this business because sometimes we find stuff that we're unable to talk about, but we want to share it with the right people. And just to sort of put us on the same page, I'd like to start with a definition of disclosure, responsible disclosure from Wikipedia. It says, in computer security or elsewhere, responsible disclosure is a vulnerability disclosure model in which a vulnerability or an issue is disclosed only after a period of time that allows for the vulnerability to be patched or mended. And this period of time distinguishes it from full disclosure, which is, oh, I found a bug, here's the POC, go play, basically. Why do I call this ultra-responsible disclosure? Well, in the OT sector, that period of time is a very, very long time in many cases. And in some cases, I mean, an O day is really an ever day because there are systems that will never go away. So, before I begin, I'd like to throw in a little disclaimer here. Everything stated in this presentation is the result of my own study of ABB systems. ABB have been informed over 5 years and had 5 years to contact their customers discreetly and have a new product out on the market that is immune to this attack I'm about to present. To date, there is still no public advisory on this, however. In no way can my customers be held responsible for any content in this presentation. This is all on ABB. And I'd like to point out that ABB is not any worse than any other ICS vendor. This just happened to fall into my lap. Usually they're really good about security, and the story is more about me probably talking to the wrong people. So that are some of the lessons learned here. Yes? No. By all means, film it all the way. Yeah. 5 years ago, an IT technician went on parental leave, and I was hired as a consultant to fill his position in a project to introduce a data historian. Data historian, I'm sure you all know, is a database for storing measurements and values and so on and so forth. We wanted to have a central data historian to aggregate from 3 of our SCADA systems. One of them was an ABB system. The other 2 were other kinds of SCADA systems. And we checked out a lot of different products, but the choice fell on an ABB product called Power Generation Information Manager. And in this project, we wanted to have a central point for our employees to do data mining and to do data analysis to predict wear and tear on pumps and so on and so forth. And of course, we wanted to make this available for our office users. So one of the requirements we had was that we wanted to have single sign-on. And however, when I came into this project fairly late, we were in the SAT and actually after FAT, so we were sitting at the SAT, which is a site acceptance test. Everything was just done, packaged, and we're just supposed to agree on, yeah, this does what it's supposed to do. However, the implementation of that single sign-on bothered me, and I started asking questions because I couldn't quite wrap my head around how the user authentication mechanism worked. And to really test this, we took a non-domain joined computer but with a correct username, and were able to log on, which was pretty bad. So That was like opening up a can of worms. Kind of, the security model was like this. So user X wants to access data. Yep, user X is authorized. I guess he knows his password. Yeah, give me this good stuffs. Okay. Dear client, please check logged on username. Not really a good security model. I mean, this is like something from 80s or 90s, doing client-side authentication with JavaScript and whatever. But this is a serious authentication bypass vulnerability. So you know or enumerate the usernames, then you get basically full access. So anyway, ABB went back to the drawing board, and they wanted to provide a new version that supported Active Directory integration. The new version was produced, and I was given the task to test the security. However, I thought this went a little too fast. It was just a couple of weeks. So I had my doubts, and I smelled blood, and basically, I figured that either they knew about this beforehand and already had a new version that was AD integrated, or this is just crap. I wanted to see, did they really do a good job of this? Or was it still possible that it's still client-side authentication? So how do I test that in an AD environment? Well, I created my rogue Active Directory with rogue user and client. And yeah, hey presto. If you look at this, there's the evil admin user, of course belonging to the correct user groups in my Active Directory, PGIM admins and PGIM users. And yeah, full access to Signal Explorer and whatever. And this is, yeah, like you see, rogue client belonging to the Active Directory evil pgim.local. So, security model. User X wants to access data. Please check that user X is logged on to the Active Directory and belongs to group Y. Everything checks out. Give me the good stuffs. We're still on a security model where we ask the client to do the security checks. So, ABB thought I was a pain in the ass and did everything to downplay this problem. It was implausible and required too much knowledge about the security architecture to be feasible. Yeah, okay. However, in the meantime, I was looking at the legacy authentication, which utilized pretty much basic authentication with a username and password, because that was a viable option for us because we didn't like the security model that the single sign-on would give us. So I was also looking at that. And we were seriously thinking about, well, just skip the single sign-on and go for the standard installation with username and password authentication. However, when I looked at that, it was another can of worms. I made an even worse discovery. Security model of the legacy system was somewhat like this. User Z wants to access data. No, I don't have any user Z in my database. Deny. All right, so user X wants to access data. Yeah, I know him. Check if he knows this secret password. Yeah, he does. Give me the good stuffs. So, dear client, please check that the user knows this password in clear text over the wire. Thank you very much. So, if I know the username, I get the password. But once I had a copy of this software on a virtual machine, I poked around a little bit and started looking at the admin interface. And Wireshark to the rescue. It turns out there were no security tokens passed at all. So I didn't even have to authenticate before asking for the entire user database. So, epic fail. I was completely wrong about the security architecture or the security model. It was more like, hey, give me the good stuffs. Okay. So, no security. Again, ABB is still trying to downplay this problem. The attack requires far too much inside knowledge to be plausible. I get a little frustrated. And, well, 30 lines of Python later, I just wrote my own client. And this is what happens. Now, I have redacted this because this was the central PGIM server we used. But my little Python script just asks for the user database and gets all the usernames and all the passwords in clear text. Thank you very much. Here we have ABB engineering and ABB maintenance passwords. Administrator password, there is the administrator local admin password for that municipal system. But I guess you probably want to see a demo, right? Yay. Let's demo. So here we have the PGIM server, and of course, we can add users, and this security charade asks me for the password because it won't let me add users otherwise, but I could write my own tool to add users as well. It's fairly simple. Don't worry, you'll see the password later. So let's add a user. Call it CS3. All right. And with the super secret password CS3 rules. All right. And I want to save that. Yes, please. And check the IP address and jump over to my evil Kali Linux. Of course, you all know the password to Kali, right? So no need to pretend here. All right, so we have my script here. If we do ignore comments, for instance, just do grep -v and pipe that to, whoops. Sorry, fat fingered that one. And what file, of course. Oh, yeah. Should have brought my reading glasses. There we go. Oh, 50 lines. Probably didn't do that. Now it's 30 lines. So 30 lines, not including the comments. Looking at the script, it's basically just takes input from the command line for an IP address. You can see all the protocol decode up there. It starts with 12A40000, and then the length of the command in little endian 4 bytes, and then it's just plain text basically. This is small talk. Don't worry, I'll give you a link so you can download this after. So, and anyway, what happens if we run this on 10.34.15.10? So it spews out all the usernames and passwords for that system. And there we have the CS3 user with the password CS3 rules. And in case you want to go in and change anything in the database, the PGIM user has safety first. That's it. No, I'm kidding. But that's the tool anyway. So anyway, that was only the engineering and maintenance accounts plus local admin on a municipal system. But when I ran this on a production server, the plant manager looked like this because what was revealed in that user database was the domain administrator password for that 800XA domain. And that is game over. Total ownage of that domain. And it's really comes down to poor implementation. I mean, this is a joke, but the usernames that were in that database didn't have to be there because the 800XA system, it doesn't need authentication to store data. So why are those passwords in there to start with? Well, anyway, I showed this to ABB and asked, well, is this still not a problem? So I guess we can tell our peers in the industry. And I had actually booked a meeting with the head of security for Svenska Kraftnät, and I was planning on talking to MSB and the CERT and everything. And apparently we couldn't. So we were served with this. It's unfortunately in Swedish, but it says classification of information as confidential to avoid dissemination and thereby increased risk for exploitation of the security problems that have been found in project so-and-so, your purchase order number so-and-so. ABB has decided to class this information as confidential according to the 9th paragraph in NLM 10, which is a standard contract for IT services. The background is that ABB considers dissemination of this information poses a much larger threat or security risk than the problems themselves. Few, if any, customers have the exposure to the problems as my customer. ABB will deal with these clients discreetly and separately. So if you're vulnerable to this, I hope they have. I can only take their word for it. Signed, so-and-so manager, power generation, and the project manager. So, guess not. But few customers that are at risk, right? The marketing says something else. 800 reference systems, and this is in 2014. Looking at Sweden, my sincere apologies if your name is here. Chances are there are some. So how did we deal with this? Well, we still needed this for the project. So we had to find a workaround. And of course, it's really not a problem if all the clients that are allowed to access this server are authenticated to begin with. So we did it by using IPsec VPN. And it doesn't matter if it's a crap protocol going over IPsec VPN tunnel. So that's how we solved it. ABB took some time, but now they have a product that's out called Symphony Plus Historian. I have tested and verified this to be not vulnerable to my, my exploit. And also the authentication model is completely different, so it does not rely on a local user database. So there shouldn't be anything, even if you were able to connect to the API. So that's good. Now, of course, I was super curious to find out, how did ABB solve this? Well, still lipstick on the pig. They did it by using encapsulation and using Active Directory to make sure that only authorized clients are able to access this system. There are some things that I haven't dug into because there are possibilities with cross-domain authentication without trust between the Active Directories. I haven't poked around, but it really doesn't matter because the big problem with a user database shouldn't be there unless you migrate everything over from a previous version, in which case there still might be usernames there you don't want exposed. So, moral dilemma. When do you tell your friends? Well, in my case, my customer classified this as secret according to national security. So I was unable to talk about this until they patched their systems, which was earlier this spring. I talked to MSB as soon as the secrecy was lifted, and have been meeting with SCADA and informed them about this vulnerability. This was earlier this fall. But it's really a huge problem. Because I wanted to share this specifically since a lot of these systems are used in critical public infrastructure, and this is a threat to national security, I understand. Anyway, so what's vulnerable then? Well, it's mainly, I would say, ABB 800XA version 5 dot something using PGIM as a data historian. 800XA version 6 may be vulnerable if legacy support is included and the usernames and that is not removed from the database. So if you convert and migrate the entire database, that user database might still be in there, so you might want to check. And anything based on Plant Connect, which is the crap product ABB bought and called it Power Generation Information Manager. All right. So, implications? Well, if I get a toehold on a client-server network running this, I win, period. I get enough credentials to take over the system. And how do we deal with this then? Well, much in the same way we did, you have to have a layered security model. You need firewalls to make sure that only authorized clients are allowed to touch that system. You can use a data diode for exporting this out from your SCADA network and to a central server, something like that, and segment this from the production networks. Like we did, you can use VPN access to PGIM. And of course, if you run this, remove all the domain users from that PGIM database because they're not used. They're not there for a reason. So go in and do some sanity checks. Use my tool to find out. And unfortunately, if you're running this, you'll probably end up finding out the same thing that my plant manager did. And the final one, upgrade to Symphony Plus Historian. But that might not be feasible in a short time. But there are mitigations that you can use to minimize this from a security perspective. All right. Guess I was a little excited because I'm all done. The source code for the assessment tool is still not, I wouldn't call it a tool, it's a proof of concept code. But it's on GitHub or Bodforss pgponer. So feel free to download, modify. I am working on a new version that includes a scanner, so you can scan networks for port 4242 and have fun with it. So hopefully there'll be somewhat more tool-like thing in that repository in a short while. Do you have any questions? Everything clear as day. Anyone in here is having a bad day? Yeah?
Wait.
So how do you think, how can you put like requirements on the suppliers to actually take the security seriously? Because this supplier is like a big one, and it could maybe be the only one that you can choose. But if this is like, it's really serious.
Yeah, I would say first of all things. Even back in 2014, ABB had a very sound security policy, specifically based on Microsoft SDL, which is really good. However, this was a product that they acquired and badge engineered into an ABB product. So if this had gone through those controls, I mean, for Christ's sake, this would have been found in a threat modeling. You do not trust the client to do security authentication, period. Everyone knows that. Apparently not the German brilliant minds who came up with this, but yeah. But seriously, it should be normal software development process. This should have been found, and unfortunately, you can't turn all the stones, and I don't blame them for that. I'm more disappointed in the way they handled this, and that was somewhat on me because I didn't go strictly directly to ABB cert in Switzerland. I went through the local organization and the local project manager, and I thought they would be able to handle this. Took me over half a year before I was put in contact with a security manager within ABB, and then it's been dead quiet until yesterday.
Yeah, congratulations to your findings.
Thanks.
One annotation, I work for the German government, and we are dedicated to removing vulnerabilities from products. So you can address us, and we keep the information, the guy who is giving the information to ourselves, and we are addressing the vendors ourselves and forcing them or pushing them as hard as the government can do to bring out a fix. So was there a fix in the end?
There is a fix, yes.
Okay,
yeah. So the new product, Symphony Plus Historian, is immune
But that's
to
a new product, not a fix for the old version. This is what I was asking for.
It's the same software, just a new name.
Okay.
Yeah. Yeah.
Thank you. Hello. Do you know of any exploits of this vulnerability?
Not that I have seen. My code is available, but I haven't seen any attempts to exploit this, and it's fairly simple to write a snort rule for this, because you shouldn't see unauthenticated user list commands. You shouldn't be seeing user list commands at all, unless you're adding a new user or deleting a new user. So just triggering on that user list command. It's a one-liner in a snort rule. So and I haven't seen any attempts. I haven't worked with a lot of customers who run this. Just one of my customers used this, but I haven't heard from MSB or any other that there have been evidence of this being exploited. However, I mean this was super simple to find, and I'm pretty certain that some threat actors, I mean, they have to be blind not to have found this. I mean, clear text passwords over the wire in 2014? Insane. Yeah.
I have actually one input and one question. The question first. How do you know that MSB is get out to the different customers that have these type of systems?
First of all, I was addressing SCADA, which is a group of people from both water and energy sector. So all the major players within Sweden were represented there. Vattenfall, E.ON, all of them, including two large water producers as well, VA Syd and Stockholm Vattenavfall. But the list was long. I mean, I'm sure that there are installations in Sweden that are vulnerable that do not know about this.
And then you will also assume that not only Sweden but Nordics, Europe. Yeah. Okay. So that. Just an input. Do you, no, it's actually been a question. It's a reference to the question from that guy over there. When you go out to the customers that buys this system, would you say that to assume and to be, do you think it's good to assume, or do the customers verify and test their systems?
Very few customers even have security requirements when they're doing. It's all based on practical requirements. It should have so and so many substations and so many IOs and things like that, and it's very detailed on that in that aspect, but very few security requirements. My customers now have security requirements, and if I hadn't been, basically, if I hadn't been on this project, we still wouldn't have known about this vulnerability. So no, not a lot of people do security testing. And unfortunately, I would say there isn't that much competence around to be able to do security evaluation of a product. But I mean, you should at least do a Wireshark and make sure that there are no clear text credentials passed on the wire. Yeah.
Yeah. Okay. Yeah. Then maybe we could give the audience and also the governmental part and input to maybe help the industry out in the procurement side to help them out with security questions. Then could that be an idea?
Yeah. Yeah.
Good.
Okay. Question here. Yeah.
We had some extra time.
So ABB used the contractual clause, paragraph 9 here. In what context? Where did that clause come from?
I don't know. I actually haven't read the NLM. So
what is the NLM?
It's a standard contract for, I believe, IT or OT products. And I think it somewhat refers to proprietary information. So, however, what's really funny about this, because this came into the security manager of my customer, and we're a public authority, which means that that one came in and was handled according to Swedish law, and then the principle of openness applies, and anyone can ask for that, and it pretty much states the problem.
Right.
So we were able to say this is classified according to national security, and everything was. But when that came in, wasn't much we could do. So it would have been better just to talk to us.
So would it be possible to amend the NLM, to specifically discourage vendors from hiding security problems behind security like this?
I don't know. I mean, had I done this again, I would have gone straight to the CERT.
Right.
Before I even informed the vendor. And then it would have been the cat's out of the box, sorry. So, yeah.
All right, thank you.
Thanks.
As a comment, in an incident the name company tried to pull that one on us, but it wasn't our system, and we're not customers, and it's not our data, so it's not valid.
No.
But it's several companies pull out that. It's very annoying.
Right. Thanks for listening.
Yeah.
It was an honor to be here. Thanks.